Welcome. What we're going to do today is we're going to talk about how to use the atomic number and the atomic mass or mass number to identify the number of subatomic particles that a particular atom has. This chart that you're looking at lists the three subatomic particles. As you know, the proton is positively charged. It is found in the nucleus, and the atomic mass is approximately 1 atomic mass unit, or AMU. The neutron is also found in the nucleus. However, it is a neutrally charged particle, so it has no charge, and the atomic mass is about 1 AMU. Now notice that the neutron is slightly, just by a little bit, slightly heavier than the proton, but they're both about the same at 1 atomic mass unit each. Now the electron, which is a negatively charged particle, that's the only particle not found in the nucleus. It is found outside the nucleus in a region called the electron cloud, and the mass is so little that we can neglect it. It's negligible. So basically it has such little mass that we're going to call it 0 AMU. Even though it does have something, it's insignificant. Now, when you look at this standard notation, you'll notice that the X represents the symbol of the element. On the top left-hand corner, the letter A stands for the mass number. And if you look here, the mass number, I also put atomic mass because some of you have heard of it as atomic mass or atomic weight, can be found by adding the protons and the neutrons. So the mass number is basically the protons plus the neutrons. Notice the electrons are not in the equation because their mass is basically negligible. It does not contribute pretty much any mass towards the atom. So the mass number goes on the top left-hand corner. On the bottom left-hand corner, represented by the letter Z, is the atomic number. Now this is important because the atomic number is the number of protons. Now notice that this corner is empty. If this is blank, that means that the atom is neutral. Okay, an atom means that it's neutral, and neutral means that the number of protons and the number of electrons are equal. So if an atom has an atomic number of 10, that means it has 10 protons, and it also means that it has 10 electrons, because again, atoms are neutral. So technically the atomic number means the number of protons, but if in a neutral atom, it will also be equal to the number of electrons. Now, you might be asked to find the number of neutrons, and this is what we do. To find the number of neutrons, what you do is you subtract the mass number, or the atomic mass, which is the symbol A on the top left-hand corner, minus the atomic number, and when you subtract A minus Z, the difference will give you the number of neutrons. So this little notation, we're going to use this to do several practice problems in just a moment. Now, before we do that, an ion, unlike an atom, if you recall, an atom is neutral. An atom basically means that the protons and the electrons are equal. An ion is a charged atom. Now, an atom cannot gain or lose protons. It cannot do that. See, the number of protons, which is the atomic number, is what identifies an atom. If you change the number of protons, you change the element. Okay? So when you create an ion, which is a charged atom, it's either by gaining or losing electrons. But you will never gain or lose protons because, again, when that happens, the element changes into a different element. Now, when you become an ion, either by gaining or losing electrons, you'll notice that the proton number will no longer be equal to the electron number. When you lose electrons, you'll see that you become what is called a cation. A cation is a result of losing electrons. It is a positive ion. That's what a cation is. When you are an anion, it means you're receiving electrons. Because you're receiving electrons, you're receiving more negative charges. So as a result of gaining electrons, you would become negatively charged. Okay? So keep in mind that if the proton number is greater than the electron number, it's because you lost electrons. Therefore, you're positive, you're a cation. If the proton number is less than the electron number, it's because you gained electrons. And if you gain electrons, your net charge will be negative because of gaining electrons. Now, what happens if the number of neutrons changes? Well, that creates another scenario called an isotope. You see, isotopes are atoms of the same element, but they differ in their number of neutrons. Because neutrons are part of atomic mass, when you change the number of neutrons, it will affect the atomic mass of the element. The element could be heavier or lighter, depending on how many neutrons it has. Now, what determines chemical properties is the electrons. We'll talk about that when we go over bonding. When you are an isotope, your number of protons and electrons do not change, only the number of neutrons. Therefore, chemically speaking, isotopes are identical to each other. They react the same way, and that's because the electron number is not touched. It's not altered in any way. The only thing, again, that's changed is the neutrons. Therefore, the atomic mass will be different. Now, here's the standard notation. So, when you look at this, okay, this element, Cr, is the element chromium. And chromium is on the left side of the periodic table. It is a metal. Notice that there's nothing written here, so it's neutral. Okay? Now, the atomic number is the 24 on the bottom. The atomic mass or mass number is the 52. So, what you're going to be asked to do is you're going to be given this notation, and you're going to be asked to determine how many protons it has, how many electrons, and how many neutrons. Well, the protons is the atomic number, and that's 24. Now, this atom's neutral. So when you're neutral, the proton number and the electron number are the same. So if I got 24 positives, I got 24 negatives. To find the number of neutrons, remember that formula. Atomic mass minus atomic number gives you the number of neutrons. So the atomic mass or mass number is 52. 52 minus 24 will give us the number of neutrons. When you subtract, you get 28. A good way to check your answer is add the protons plus the neutrons, and if they add up to 52, which they do in this case, you know that you did that right. Notice the electrons are not part of finding the electrons are not part of finding the atomic mass. Here's the solution that we just did. So you'll notice that they found the neutrons by getting the mass number minus the atomic number, as you can see there. Okay, it was 28. And again, in this example, it was neutral. Now, let me show you the exact same example, but I'm going to alter the example for just a minute. And let's say that there was a charge. Okay, it was 3 plus. What this means is that you lost 3 electrons. That's what a positive means. This is actually a cation. So before, the proton number is still 24. Now before, the electron number is 24. But a plus 3 means that the proton number and the electron number are no longer the same. So you used to have 24 electrons. You lost 3. So you're left now with 21 electrons. And the neutron number is still the same. You do 52 minus 24, which is 28. So notice how the electron number changes when there's a charge. Okay? Let's take another look at, let's look at another example. how many protons and neutrons are in the potassium isotope? So again, here's the mass number on the top, atomic number on the bottom. K is potassium. In this notation, it's neutral. Okay, K is also an alkali metal. It's part of group 1, and it's a metal. And because this is a neutral atom, the proton and electron number will be the same. The number of protons is the atomic number, which is the bottom left-hand corner. So there's 19 protons or 19 positives, which means there's also 19 negatives. And then when you do 39 minus 19, that's how you find the neutron number. Okay, you get 20. And again, 19 plus 20 will give you the atomic mass or mass number. All right. Now, again, if we were to put a charge, remember when you don't write a 1, or when it's a 1, you don't need to write the 1. So when you see a plus by itself, it means plus 1. If you see a minus by itself, it means minus 1. Here, proton number is still 19. But this means you lost 1 electron. It's a cation. So instead of having 19, you now have 18 negatives. And again, the neutron number is still 39 minus 19, which is 20. Okay? Now, let's do this. Let's go backwards. And let's say that we had, I gave you these 3. Okay? And let's say I gave you some numbers here. Let's see here. So we got, you're given these 3, and we want to fill in the blanks here. We want to find out who the element is, which is letter X, okay? We want to find the mass number, the atomic number, and the charge. So, first thing I would do, go to the periodic table to see who has an atomic number of 26, who has 26 protons, because the atomic number is the protons. And when you look in the periodic table, you will see that the element with the atomic number of 26 is iron, which is Fe. So that's our symbol. Now remember, the atomic number also goes on the bottom. Okay? The next thing you might want to do is let's find out the top number. Let's find out the mass number. So remember that A can be found by adding the protons plus the neutrons, which is the mass number. So you add these 2 and you get 56. So that's the top number here. Now, notice that the proton number and the electron number are not equal. So there's a charge. Okay? There are 26 positives and 23 negatives. That means that you lost 3 negatives. So when you lose, you're positively charged. So this guy is plus 3. Just like that. Okay? Now, there is another notation that I want to show you that's similar to this one. And I'll use this same one. There's a notation that instead of writing, we just found out that this is our notation here for the iron. Now, the previous example, I made it an ion. In this example, I'm going to erase that, and I'm going to make this neutral, because this notation that I'm about to show you, it's called isotope notation. And in isotope notation, the atoms are neutral, which means the proton number and the electron number will be equal. And what you do is, to write this in isotope notation, instead of writing the symbol, you write the actual name of the element. And then you put a dash. That's not a negative. And after the dash, you're going to put the mass number. So you're going to put iron 56. So the number after the dash will be the mass number. It's another way of doing the notation. Okay? Let's take a look at another one here. Let's say I had chlorine 37. Okay? So in this notation, again, it's neutral. So we know that these 2 will be the same. Chlorine is Cl. Okay? Remember that this is the mass number. So that'll go up here. And then what you'd have to do is go to the periodic table to find out what is the atomic number of chlorine, and you'll see it's 17. And that would be the equivalent of this notation. And if you wanted to find the protons, the electrons, and the neutrons, well, the atomic number, as we said, was 17. And in this notation, it's neutral, so we got 17 of each. And to find the neutrons, you do 37 minus 17, and that'll give you 20. Okay? And that would be the number of each subatomic particle in chlorine 37. Okay? Let's try one more. Let's say I had this one here like this. Again, it's negative. It's an ion. Remember, we don't have to put the 1. And you got to remember that this means you gained 1 electron. This is an anion, which is a negative ion. And let's do the following again. Let's find out how many protons, electrons, and neutrons. So here, the atomic number will tell you the protons, but because of the charge, the proton number, okay, is not equal to the electron number. In fact, a negative means you gained 1. So you had, and let me fix this. I wrote P here by accident. Let's put here 9. And normally you would have 9 electrons, but you gained 1, so now you have 10. Okay? And then remember, to find the neutrons, you subtract the mass number minus the atomic number. So 19 minus 9 is going to give you 10. And that's how you would do this. Okay? We'll finish with one more. So let's say we had the following numbers. Actually, let me put the electrons here next. I'll keep using the same order. So imagine we had something like this. And we want to go backwards. And notice these are different. So there's going to be a charge here. If they're the same, you leave that area blank. You don't put anything where the letter C is. The mass number, as you recall, will go on the top. The atomic number goes here. So when you're going backwards, the first thing you should do is look at the number of protons, which is the atomic number. Go to the periodic table, which you'll have available, and find out who has an atomic number of 7, and you'll see it's nitrogen, which is the symbol N. Now remember, the atomic number goes on the bottom left-hand corner in our notation. Now notice, if you have 7 protons, you should have 7 electrons, but notice you have 10. You have more electrons than protons. That means you gained electrons. In this example, we gained 3 electrons. So your charge, whenever you're gaining, your charge will be negative. So this is -3, okay? And that goes on the top right-hand corner. This is an anion because you are negatively charged. And then again, to find the mass number, what you do is you add the protons plus the neutrons. 7 and 7 is going to give you 14, and you place it there, okay? So we have 2 notations, all right? We have the standard mass number here, atomic number. If it's neutral, it looks like this. Okay, if there's a charge, there'll be something written over here. And then you got the isotope notation. I'll use an example of a famous one, carbon-14. Okay, and in this notation, remember that the atom will be neutral. So for this notation over here, if we were looking for these numbers, you'd go to the periodic table. You would look for the atomic number of carbon. Carbon happens to be 6. Since this notation is neutral, the protons and electrons are the same, so they're both at 6. And then what you do is, this is the mass number, 14. So to find the neutrons, you get the mass number minus the atomic number, which is 6, and you get 8. And that's how you get the 14 there when you add the 6 and the 8. Okay? If we were switching it to the other notation, this would look like this. It would be carbon as the symbol. Okay, you would put the mass number up here. You would put the atomic number here, and you would leave this corner over here on the top right-hand corner blank because there's no charge. Okay? So these are two very popular notations that we will be using.